go and did a spreadsheet of the last 2 years or 3 years of all my kilowatt usages with the old boiler, without a boiler. Then now I'm working on a year with this boiler, then I can compare. But I've also, I've already seen that we've seen a tremendous amount of savings with the boiler when it comes to kilowatt hours. I had a wood boiler, coal boiler. I could burn either one on an outdoor wood boiler before, but it went bad on me last June, so I was looking for something that was more automated. So I found this coal gun out of Pennsylvania. They said it burnt anthracite coal. They ain't never sent one this far west, so I'm up here in southeastern Montana, so I went ahead and bought it. We have a bunch of bituminous and subbituminous coal out here. I went ahead and bought it, built the building, put it in it, because everything I had was plumbed for outside. I heat my shop and my house and all of my hot water. My house is, I don't know, just a little shy of 3,000 square foot. My shop's right at 1,200 square foot. And so we heat all that with this Coal Gun 130. It's doing really well. I've had it fired up now since late July. Had to go through a lot of tweaking and getting everything tuned in. But now I found the sweet spot at 133 degrees on my ashing. So it ashes at 132 degrees. Once you got a good fire in there, it hardly even ever smokes. You'll just have initial smoke on the startup. Once it gets this stack hot and start burning that gas, you won't have any smoke. Right now with this manometer, I'm pulling at about 0.06, 0.07, but I'm only going up 12 feet from here. It's, this is 12 feet of pipe straight up, so this is just a straight shot. Don't have any bends in this pipe at all. The fire on this deal, there's your fire right up in there. So what happens is when that fan kicks on, it sucks this damper closed. So now all of your oxygen, all of your air has to come in from underneath and come through your coal bed, and that's what ignites all your unspent coal. So you've got to have a pretty good layer of hot ambers and hot coal down in here. I'd say a good layer. And you saw that I had some coal, some ashes up in here, up fairly high, but that's just the outside layer. That's just when this thing opens up, it'll ash up a little bit in there. But if you get that coal bed too low and you put too much fuel on top of that, then you smoke like crazy. Bring that ash up high and let that red ash just sit there and just kind of go up and down. And that new coal sits on top of that. It ignites with no problem, and I'm talking like less than a minute, it'll be lit. Okay, this pump right here that doesn't have a light on it, you'll see it come on. Okay, that pump right there will pump to the garage. As soon as this dump zone kicks on to 200 degrees, as soon as this water temperature hits 200 degrees, it'll turn that pump on and circulate it, and it will just dump all your heat into the garage and get this thing cooled down. I normally keep it off. I got a bypass switch here because I don't want stagnant water sitting in there too long, so I installed me a bypass switch just right there. So I just wired it up in parallel with the dump zone switch, and every now and then I'll turn it on and then I'll just turn it off, and I'll just keep water flowing periodically. This other switch here, that actually I got it set, that's my operating limit. I got it set for 160 degrees. So at about 159 thereabouts right here, the the fan will kick on, and then it will kick off when it hits about 175. It'll actually kick that fan off and then open up this damper that we talked about a little bit ago, and then just let all the oxygen come into the top of that fire and then out the stack versus being fed from the bottom. But I'm fairly impressed with this. Right now, here's the coal that I'm burning. I mean, I just got to bust it up, and I got big pieces. I got lump coal, so I take my hammer and I bust it up. This hopper will hold about 6-gallon buckets from start to finish. I mean, from the very bottom. But if you just maintaining coal down in here, you got to keep coal in there. You got to keep that weight of that coal in this hopper to come down this pipe. I'm finding that out. You can't really get that hopper too empty because it needs that weight and that gravity feed to feed that down on top of that ash. And I'm also noticing too the ash pan. I can go probably 5 days and I got to empty that ash pan, which isn't a whole lot of ash, but it retains that heat so much. My ash is more like a fly ash, and it retains that heat so much that it I've got to keep it empty about every 5 days, pull the ash out. I got 2 zones on this unit, one for the shop and one for the house. The house is a continuous loop, and inside the house I can split half that loop off with bypasses and have a continuous loop just for that water heater. So it's the same loop that heats my hot water and my furnace, but when I'm summer mode, I use this year round to heat my hot water. So I just bypass the furnace, and then we just continuously heat our hot water. And right now my wife is actually in the house taking a shower, and I had the one in the shop on a little bit ago just to get this thing rolling. Now we're coming back about 150 degree water. So the water coming back is about 150 degrees is my return water. My boiler water is right at 160. So right now I'm heating up my hot water in the house because I know my wife's in the house taking a shower. So the only thing on is the loop going to the house. So right now about a 10 degree difference trying to heat up keep that hot water heated. That old boiler I had was an open system. I didn't have expansion tanks or any of that kind of stuff going on, but this one I had a fill valve, I had to put expansion tank in, and they recommend all that on these closed loops. To burp your system, it's pretty cool. I got these valves here, so you basically shut off your valves going back. I got my pumps on my return, so I'll close these valves here, and I'd go and hook up a garden hose here, and then I'll crack open that valve, and I would just push out. I'd open up my feed valve over there, and once I got my water flowing through my feed valve and through the boiler and whatnot, or I actually got valves so I can just go right through my supplies to the loops. It'll just go through the loop and come back to the loop, and then once I get all the air burped out, I know I'm good on these pumps. I know all the air's out. The original footprint of that boiler was where these pipes are coming out of the ground. That was the back of the boiler, and all these pipes came into the back of that boiler. I added on I went 8 foot out, made a 14 by 8 foot pad here, and pinned it and drilled it and tapped it and everything, and tied into the existing pad, and built this room because these boilers, they say, were designed for basements and whatnot, so I couldn't just stick it outside like the old system. So I insulated this. I'm in the process of finishing it up, and then I'll end up having an auger coming through the wall into my coal room. As soon as I get all this coal out of here, then I can put fresh coal in. But and I'll insulate the pipes and get all that going. Try to retain as much heat as I can in my system. It ashes on temperature. The ID fan, the blower, will actually be energized when the water temperature drops and it says, hey, I need some heat. So this motor will kick in, and it's sucking air from underneath through here and then through the gun part and then on out. And when the temperature drops on the ash, this other motor down here, reduction geared motor, it'll actually kick in and it'll start rotating in there ever so slightly. It'll move that ash pan or that ashing plate, and as it's doing that, gravity takes over and more coal will fall in. So basically your water temperature controls the side D fan, and your ash temperature controls the feed of your coal and the ashing of your ash. Here's that fill valve that I talked about. This one's rated for 15 psi. I turned it down to try to get about 12 psi on the system because I really don't have too far to go. I'm not pushing a whole lot ahead. Here's the backflow preventer. It's like I want to be able to, if I had to change any parts out, I can do this by valving anything out. So I've got a valve here, and over here I can actually change my expansion tank out or my feed valve without interrupting a lot of water or anything like that. I can just change everything out without doing with valves and ball valves, and I'll cycle them every now and then just to keep them freed up. I put this valve in. I didn't take it out since I put it all together, but this valve here I put just to pressurize this up with air, and I let it sit for about 24 hours with air in it before I actually put water to it, because I didn't want to waste the rust inhibitor and whatnot and the chemical I was supposed to put in this thing for the firing. I didn't want to waste it by putting it in there and then I ended up having a leak. So I put air to it for about 24 hours, and then I had one little leak and got that fixed and kept more air to it, and it held pretty well, so I went ahead and put water to it, but I just never took that off. You might need it one day. Like I said, I got unions, sweated unions in there, so I can actually break this union free. I can break the union free on my hot water. This is my domestic hot water, and once I break those two unions, break this union here, valve things out, I can actually, and over there on the supply or the return, I can just take this thing out if I ever had to, God forbid. Of course, you got your air scoop here, it takes out your air, so now it's just this system has no air in it whatsoever. I mean, this is open, has no air in it, has a little plunger in here. Those of you who are familiar with these closed loop know all that. I'm going to get rid of this. If anybody's wondering, I got dissimilar metals here, I know that. So I got me some hangers, and like I said, I'm not finished with the ceiling, so I'm going to put some all thread through this copper hanger and get my pipe hung right, just to relieve pressure if there was ever any. The controls to this is pretty neat. Right now my ash is set for 133. In there right now it's 137. This one here was actually done with the timer for your ashing, and it had a pause setting in there. I went ahead and turned that down to very minimum because I tweaking in this, that, and the other. I just didn't see that I needed to actually pause on my ashing, because it don't ash for very long. I mean, it just ashes until it catches up to temperature and then it stops. So I didn't want to do a pause. You got circuit breakers in there. You gotta start a little mag in there. So this is all your controls in there. It's not really complicated. Yeah, I'm sticking my hand all the way in that. I'm not even burning my hand. It get black, but it don't get, I mean, it's not all that extremely hot. And that's because that damper's opened up and I'm pulling air on top of the fire, and I'm not pulling air from the fire, so I'm not sitting there burning my coal. You see that fire's just barely going in the backside. It just came up a little bit more since I opened it, but it just barely, it just sits there and idles. And then it'll kick back on here in a bit, probably when I go take my shower. The key thing is when you want to fire this thing up for the first time, hit that light again. Make sure you got a good bed of coals in there. And if you don't, start that thing up. I started this thing up with some match light. I put in a bag of match light, then I put in some coal, And then I went ahead and lit that match light and let that thing get to going real good. Then I started adding coal to this, getting me an ash bed built up. And I didn't ever take to heart exactly what they said. I was actually talking to the outfit here, and they're saying, well, make sure you got demand on it. Okay, I got my hot water heater. That is not the demand they're wanting you to have. You get that hot water heater, you get a good demand on that. Turn on your furnaces, good a demand on that. Get this thing that's calling for heat, and let it call for heat for a while, because you want that ash to get built up nice and hot. And if you don't, the water temperature is going to come up to temperature, and then it's going to shut everything off, and you're just going to have all this fuel on top of a little bit of coal, and then you're just going to be smoking and back puffing, and you're going to go through that for a while. But once you get that good bed of coals in there, a good bed of ash, and you got a good demand on it for a long time, make sure this hopper stays full and empty that ash pan periodically. You don't want that ash to keep building up in that pan, because that's residual heat. Get rid of the heat, and then your thermocouple will actually work off of the true heat of the ash and not residual heat. And the weight of this will actually help push that coal down. But they say to make sure you got a good load on it. Make sure you got a good load on it. And I was a slow learner when it came to that, and it took me a little bit, but I finally got it figured out that you got to have a good bed of coals in there, a good bed of ash. This damper's fixing to open up. Let that draft go down. There it goes. Just open up that damper, and there's our fire. And see, we did a little bit of ashing, so we got new coal on top of the ash that was sitting there. With this little fire right there, it'll actually die down, but this is hot enough, it'll ash up a little bit more. But that weight of that coal, you got to keep these things full. You got to keep these hoppers full of coal. You got to have that weight pushing down, is what I'm finding out. And you got to get rid of ash. I mean, if your pan is ash, if you got ash in your pan, you don't need to get that thing all the way full before you dump it. Dump it when it's, I dump it when it's about 4 or 5 inches deep, and get it on out of there. And that's just less heat that's retaining in there, that's keeping that ash, hit the switch, that's keeping that thermocouple hot. You want to keep that thing true to what's on the ashing plate and not what's in the pan. They say to clean these things, there's 2 videos about cleaning these. And they take this motor off, these 4 bolts here, they take this fan out of here, and there is a video that they put out there that tells you how to clean that. It's really simple. Same thing with this here. This is going to be a little bit different. Like I said, I'm straight up. I don't think I'm going to need one of these dampers in here, but we'll see what happens when it gets about 40 below outside. But right now I'm not even, I can have this thing wide open and it doesn't really change my draft at all. But you can take this thing right out of here. This pipe will stay in place, but I can lift this up out of here, and then you take these 4 bolts off this flange, pull this out, and there's a cleaning port, and you got to clean that cone and all that other stuff that's inside of here. So there's a video out there on that as well. One piece more pipe I gotta sweat is I'm gonna sweat my my pop off. This does pop off at 30 psi, because when I pressurized the system with just air, I tested that. I went to just right at 30 psi, and that pop off did pop off. So that was good to know. It doesn't take long at all to get up to temperature. I've had this thing operating in 100-degree temperature and down to about 40 degrees. It gets about 50 to 40 degrees at night. We keep it running continuously. I'm just now starting to feel comfortable to leave town for a 4-day weekend and come back. I do have a guy that comes by and just monitors it, checks it for me, and sends me pictures. He doesn't tweak nothing, he doesn't do anything, so I'm just now getting comfortable. It's a new system. It's something I got to figure out and learn, and we're getting there. But I think we're pretty much there. I think we got it dialed in right where we need it in the temperatures that we're dealing with right now. Like I said, we'll have to tweak a little bit more, I'm sure, when it gets down to 40 degrees, but the ashing, see how much it ashed. This isn't much at all, but I can get some out of there. But anyway, this is fly ash. Of course, I got some unspent coal right here, which isn't very much at all. But I don't get much clinkers. Let me get up in there real quick, and I'll get you some ash, and I'll show you what that looks like. We got a little bit of sample. Of course, I just dug a little deeper and got some coals in there. But really, that's really a lot of what I do get. I get a lot of that. This is not normal for right now. I'm not normally getting this stuff, but since I dug in there a little deeper. But it's more fly ash, so I don't get that clinker.